All right, my fellow grade 12 learners, now let us quickly get into the grade 12 number pattern sequences and series. Right, so I know that as per your grade 10 and grade 11, you are only dealing with what we call your number patterns. Now you're asking yourself, what are sequences and what are series? Right, okay, so don't be alarmed. I will just go with you through that so that you get to understand how we get to that. Right, so let me quickly just do a grade 10 revision with you. I won't stay much there, but it's just to give you a glimpse of what has been happening since your grade 10. Right, so this was also introduced to you in grade 9, but in your grade 10, you were doing what we call your linear number patterns. Right. So you're doing what we call your linear number patterns. So this is where, when you did your patterns, you had what we call a constant first difference, right? So for example, let's say that you have a 2, you have a 7, you have a 12, and you have a 17, right? So what you would do then, you'd say, okay, these are terms, right? So that will be term 1, that will be term 2, that will be term 3, that will be term 4, and be careful that this is not your school term, right? Okay, so what you now have to do is to find the difference between the terms. So that will be 7 minus 2. So always when you calculate your differences, that will be the term in front minus the one and the back, or right. So that will be term 2 minus term 1. So that will give you a 5, right? So you can see that 12 minus 7 will also give you a 5. A 17 minus 12, that will also give you a 5. So now you can see that indeed there is a pattern here, a pattern of 5. So what we're getting is that the first difference in a linear number pattern would be the same, or it will be equal, right? So please make sure you grasp this concept. It's very important. We're going to need it and we're going to use it as we go along, right? So don't lose it. So, okay, I'm sorry for those who holding back. I know you just want to get into the grade 12 stuff already, but please, it's good and important that you grasp this grade 10 stuff as well. I'm not going deep into it, just going through it. Right, so now let us go to what you were busy with in grade 11. Right, when you got to grade 11, you were introduced to what we call your quadratic pattern. Right, so you're introduced to what we call a quadratic pattern. Right, so before I just get into the quadratic pattern, in the linear pattern, you have the formula or a general term, which is Tn is equals to Bn plus C, where C represented your term 0. This represented your term 0, and this would represent your constant difference. So in this case, it would mean your constant difference would be the 5, right? So your term 0 would be the number that you would get going this side, which would be term 0, right? So if you still don't understand this, don't be alarmed. I'll put this under the grade 10 video, right? So now it's just that we're in grade 12. I don't want to get deep into grade 10 and grade 11 stuff. This is just me highlighting what you guys have been doing since grade 10, right? So now we said we're going to quadratic number pattern. So in a quadratic number pattern, what was significant about a quadratic number pattern? So in a quadratic number pattern, you were dealing with what we call a second difference. So let's say you had a 2, you have a 5, you have a 10, you have a 17, you have a 26, right? So what you do there is to find the differences. So there will be term 1, there will be term 2, there will be term 3, term 4, and term 5, right? So finding the differences here, there will be 5 minus 2, that would mean there will be 3, that will be 10 minus 5, and that would be 5, 17 minus 10, that would be a 7, 26 minus 17, that would be a 9, right? So now you find the differences on the first differences. Again, that will be 5 minus 3, which is 2, 7 minus 5, that will be 2, that will be 9 minus 7, that will be a 2, right? Okay, So now we have what we call a second difference. So you can see already that on the second difference here is equal. So you'd see that on the linear, the first difference would be equal, but on the quadratic number pattern, only the second difference is equal, right? Right. So please grasp that. It's a very important concept that you're going to be needing going forward as well. Okay. So on this one, you use the general formula, or you find the general term using Tn is equals to an squared plus bn plus c, right? So here, for you to find these numbers a, b, c, you were introduced, or you were told that a here, or the first number in this second difference, would be equals to 2a. So 2a would be equals to 2, which is the first number in this second difference. So you'd solve for a in that case, right? Then you are again told that 3a plus b would be equals to the first number here, which is 3. So 3a plus b would be equals to now 3, right? So meaning what you got here, you would also substitute to a here and solve for b, right? So in this case, you now have b. What would you be left with now? That would be your c. So c, because I don't have space, would be equals to a plus b plus c. So a plus b plus c would be equals to 2, which is the first number in the quadratic number pattern, right? So from there, you just solve for c since you have a, and you would have solved for b in this case, right? So I'm also not staying there, I'm just highlighting, right? So this is your grade 11 and this is your grade 12 stuff, right? So now let us go to what you've guys been waiting for, which is your grade 12 stuff, right? So when you get to grade 12, now we are introduced to something that you've never heard of. Maybe you've heard of, but you didn't understand, right? So now we are getting into what we call your arithmetic sequence, right? So now, what is an arithmetic sequence? Now, don't be alarmed again. An arithmetic sequence is something you've actually seen before. It's something that you've been kind of exposed to. So an arithmetic and a linear pattern, I would say it's just the same thing, or I'd say an arithmetic sequence, it's just a linear pattern that now went to private school, since that is what we say to things that are familiar but are now fancier, right? So that would be the same thing for arithmetic sequence. So it's the same thing, it's just an arithmetic sequence, it's a linear pattern that went to private school, but it's the same thing basically, because the concept is still the same thing. So for example, right, in an arithmetic sequence, we are still expecting to see a first difference, right? So you'd see that the only difference there would be now the formula that we use. So we now won't be using Tn is equals to Bn plus C. You can still use it, but I wouldn't advise it, right? So, but at the end, you're still going to be getting the same answer, right? So that is why I'm saying that you can use it, but I don't advise it, because I don't want to stick to the things that you've been doing in your grade 10 and 11. Just grasp what you're getting now in your grade 12, right? Okay. So in an arithmetic sequence now, let us say you have a 1, 3, 5, 7, right? So here, the same thing as a linear pattern. You'd still be using the first difference. So if you can see here, this will be a term 2 minus term 1, that will be a 2, 5 minus 3, that will be a 2, 7 minus 5, and that will be a 2 as well. So now in an arithmetic sequence, you're now using Tn is equals to a plus n minus 1 times d, right? So now what does this mean? So a would be actually equals to the first number, or the value of the first term. So that will be the value of the first term. So in this case, the first term, or the value of the first term, would be 1. Right. Okay. So now what is d? D would now represent the difference or the constant difference with its sign. So in this case, your constant difference would be 2. So it would mean that D would be equals to 2, right? So you can basically see that this is just a linear pattern, but the one that went to private school, right? So, for example, now when they tell us find the general term of this arithmetic sequence, you'd simply just say, okay, now I have the formula. So Tn would be equals to, what is A? 1 plus n minus 1. What is the difference? 2. Right, so Tn would be equals to 1 plus 2 times n, that will be 2n. 2 times negative 1, that will be minus 2. Now, so like terms together, so 1 and negative 2, so that will be 1 minus 2, and that will give you a negative 1, right? So let me just put it as 2n minus 1, right? So that would be your arithmetic sequence or general formula or term for your arithmetic sequence, right? I hope that this makes sense. If you can test it using the one you've been using in grade 10 and 11, you see that we're still getting to the same answer. So now that's up to you now to see, okay, which one is convenient to me, right? Perfect. So that is the end of what we call an arithmetic sequence, right? So I won't go deep into the proofs and everything. Do a separate video for that one, right? Okay, so now let us go to another concept that you're going to be meeting in grade 12. So you're now going to be meeting what we call a geometric sequence. So now we have two types of sequences in grade 12. You have an arithmetic sequence and you have a geometric sequence, right? So you can also say and try your chances or luck and say that you have a quadratic sequence, but not really. Let's not use that word. So you can just call it a quadratic pattern for now. But in grade 12, we're just dealing with what we call an arithmetic and a geometric sequence, right? So let us quickly just get into your geometric sequence. Okay, so let me quickly just remove that. Okay, so now let us get into your quadratic. No, let us get into your geometric. Sorry about that. So let us get into your geometric sequence. Now, what is a geometric sequence? Right, so now this is the first thing that you've ever heard of now. You've never dealt with a geometric sequence. So what is a geometric sequence? Now, let us take, for example, that you've been given a sequence of a certain number here. Okay, so I'm thinking of a number that I can use for my geometric sequence here. Okay, so let us take that. Maybe I have a 1 over 2. I have a 1 over 4. I have a 1 over 8. I have a 1 over 16, right? So for a geometric sequence, right, there's something special that we're dealing with here. So remember, in a arithmetic sequence, we were dealing with a constant difference. Now, in a geometric sequence, we are dealing with a constant or common ratio. So now, what is a common ratio? So you'd see that here, for us to move to 1 over 2 to 1 over 4, we need to multiply by 1 over 2. So 1 over 2 times 1 over 2, that will be 1 over 4. So for us again to move from 1 over 4 to 1 over 8, it will mean we need to multiply by 1 over 2. So you see that 1 over 2 would now become your common ratio, or it was what we use to move from sequence number 1, term number 1 to term number 2. So the way in which you calculate a common ratio would be R. So we're going to use the symbol R to represent our common ratio. So our common ratio would actually be equals to term 2 over term number 1. So it will mean that 1 over 4 divided by 1 over 2, then you'd get your common ratio, which would be equals to 1 over 2. So in this case, it will be 1 over 4 divided by 1 over 2, and we get a 1 over 2. So that will be our common ratio. So here we use a general term of Tn is equals to A times R to the power n minus 1, right? So A would still represent the value of the first term, and R will represent your common ratio. So n will just be the number of terms here, meaning that if you want term number 3, you simply just substitute 3 and find the value. So Tn here will represent the value of the term. Right. So for us to get the formula here, it will be Tn is equals to, what is the value of the first term? In this case, it will be 1 over 2. That will be 1 over 2 times, what is our R? 1 over 2 n minus 1. Right. So that would be how we get our formula there. So now from there we are done with your sequences, right? So we now move on to your series. So I'll do a separate video on that one so that I don't make this lesson to be a long, right? So it'll end up now being overwhelming for you. So I'll just end here for now, then now go on to check the another video on series, right? Thank you. I hope that you enjoyed this video, and please make sure that you subscribe to our channel, click that notification button there, right? And please make sure that you go on to our other social media platforms, you follow, you like, and you share with others so that they get this useful information. Thank you so much.